Now we're going to dig a little bit deeper into the relative reactivity of aldehydes and ketones and some features that can make them more or less reactive. So the first is conjugation. And we know that conjugation goes hand in hand with resonance, and conjugation will increase carbonyl stability, and likewise, that decreases carbonyl reactivity. So let's look at a couple of compounds to make a comparison. Okay, here is a ketone attached to cyclohexane. And we'll compare that to a ketone attached to benzene. So in the first compound, we have the carbonyl, but it's not conjugated with anything. But now compare that to the one that's attached to benzene. Here we have the two p orbitals on the carbonyl, and then you have a p orbital on every carbon of this aromatic ring, so that is a completely conjugated system. Conjugation enhances stability, so that makes the carbonyl more happy as it is, so it's less reactive. Think of it like this. Why would it want to react with something if you add a nucleophile? That's going to break this pi bond, and that's going to take away the conjugation between the carbonyl and the ring. So if it's happy as is, it doesn't want to react with something else. The second thing that plays an important role on reactivity are steric effects. So let's take a look at 3 different carbonyl compounds, and we're going to compare them. The first is an aldehyde. The second is a ketone. And the third is a ketone with a tert-butyl group. Okay, so with all of these, we're kind of remaining consistent with the CH3. So we have the CH3 group right here, and that's consistent. But now, if you look at the other group that's attached, and think about the size of that group. A hydrogen, that's a pretty small group. So what that means in terms of a nucleophilic attack, if we take a nucleophile and you go to add that to the carbonyl, that's quite easy. Okay, now as we move up to the CH3 group, this group becomes a bit larger. So let's just say this one is medium size. So now as we go to add the nucleophile, it's still certainly possible, but it's a bit more difficult because it runs into this bulky group. But then as we move up to the really bulky tert-butyl group, this is a large group. So we have those 3 methyl groups. That bulky group takes up a ton of space. And what that effectively does is it hinders the carbonyl from the nucleophile. Okay, and I'm not saying it's impossible, but it makes that nucleophile squeezing in much more difficult. So steric effects play a big role here. Of these three, the aldehyde is going to be the most reactive. And the ketone with the tert butyl group is going to be the least reactive.